Hey everyone, this is another little sampling of the volume problems assignment. I'm going to pick a question somewhere on the assignment, and then I'm going to go ahead and go from there. So I'm going to pick a question, we're going to do it together. If you need help on any other questions or extra clarification on the question that I do, reach out please, because I'm happy to help you find folks. So let's think about this. What do we want to do here? Um, I'm going to pick number four. Number four is a little bit on the sneaky side. And yeah, number four does have a little sneaky component to it. So we're going to go ahead and we're going to do number four. All right. So what's number four say? Tennis ball has a radius of 6.8 centimeters. A cylindrical container is designed to hold 3 tennis balls. What's the radius and height of the container? How much of the cylinder volume is not used by the tennis balls? So, let's see if we can draw a shape here. I don't know. That doesn't look like circles. I'm gonna have to do this freehand, so we can all marvel at my bad artistic skills, but hey, that's okay. So here we go. There's a tennis ball. There's another tennis ball. And there's another tennis ball. All right. Now, what we know is we're going to have a cylinder that holds all 3 tennis balls. And what we know is the radius of one tennis ball is 6.8 centimeters. That's actually like you wouldn't think it, but that's actually enough information to figure out the answer to part A. The radius of the container, even though my container is not drawn to scale by any means, the radius of the container is actually going to be the same as the radius of a tennis ball. And the radius of the container is going to be 6.8 centimeters. Now, the height gets a little bit tricky. The height gets a little bit tricky because we have to figure out how many radiuses are there from top to bottom. Well, there's a radius there. Um, there's a second radius there. Third radius. Fourth radius. Fifth radius. And sixth radius. So there's 6 radii. So in other words, to figure out the height of the container, it's actually going to be 6 times 6.8. Which is going to be, I think it's going to be 40.8 centimeters. I am going to double check because I do want to make sure that that math is correct. So let me double check on my calculator here. 6 times 6.8, and that is 40.8. So yes, I did have it right. So that's the radius and the height of the container. So that is part A. Now let's take a look at part B. How much of the cylinder volume is not used by the tennis balls? So there's a couple things we need to do here. We need to find the volume of a tennis ball and then the volume of the container and then compare those. So the volume of one tennis ball. Volume of a sphere is going to be 4/3 pi r cubed. And the radius here is 6.8. Now, of course, we are going to use the calculator here. So we're going to find out what 6.8 cubed is, which would be step 1. Then we're going to multiply it by pi, and then by 4 over 3. So how do we multiply by 4 over 3? Well, we multiply it by 4, and then our last step will be dividing by 3. So I'm just working it out here, 4/3 pi, and then 6.8 cubed. So the volume of one tennis ball is 1,317.09 centimeters cubed. Now let's find the volume of the entire container. So that is pi r squared h. R is 6.8. H is 40.8. And that's an ugly 2, so it's a squared. So let's figure out what that's going to be. Okay. So we have pi. We have 6.8 squared. And then we have 40.8. And what we get is 926.90 centimeters cubed. Now the thing to keep in mind is that this is the volume of one tennis ball. 3 tennis balls fit in the cylinder. So to answer this question, we're going to have to take 3 of those tennis ball volumes and subtract that from the volume of the cylinder. So we'll do that over here, the volume. Oops, want my pen, not my highlighter. There we go. And here we go, volume is going to be, we could do this all in one step. It's just going to be 5,926.90 minus, and again, the key is the 3 times 1317.09. Just remember your order of operations. Multiplication comes first. So you might just want to do that separately. 3 times 1317.09. And then taking that number and subtracting it from 5,926.90. And when we do that, we're going to get 1,975.63 centimeters cubed. That's the leftover volume that's not occupied by the tennis balls in the cylinder. So that's how you do number 4. If there's any other questions in this assignment that are giving you any kind of hassle or trouble, then email me, fire me a message on Facebook, comment on one of the posts, call me on my school phone, find some way to reach out, and we'll help get you on the right track.